Thank you. All right. Hello, everyone. So the title of this talk is Just Because AI Can Write Your Tests, Should It? So let's start with a poll. So those of you who think AI should write your tests, raise your hands. Oh, it's pretty good. Okay. Those of you who think AI should definitely not write your tests, raise your hands. You did it twice, sir. And those of you who are like, raise your hands. All right, great. All of you raise your hands multiple times. Fantastic. Yeah, no, I'm kind of with you. I would just raise my hand for all of them too. I agree. All right, so that's what we're going to try and figure out today, right? And this is a topic that's actually come up quite a bit in my conversations with people over the last year, especially as people are moving towards using AI to write your code. It's like, well, if AI writes your code and writes your tests, that sounds kind of scary, right? So it's a big topic and one I think that's worth exploring. So that's what we're going to talk about today. But first, oh yeah, this is me, blah, blah, blah. Follow me online, great. Okay, I'll flash that later too. No, first I want to talk about bees. And this will somehow become relevant later. So let's talk about bees. Everybody knows the honeybee. If you search Etsy for bees, which I do quite a bit, you're gonna see honeybees freaking everywhere, right? Like there's honeybee earrings and honeybee necklaces and honeybee shirts. And it's just, if you like an alien was coming and trying to figure out what a bee was, they would assume that a bee is a honeybee, right? So yeah, everybody knows the honeybee. And I know the honeybee well. This is a honeybee from my yard. This is a female because you can tell she's got a pollen basket because only the females collect pollen because the males don't do anything. No comment. But there you go. So that is the Western honeybee. They're lovely. They're awesome. I love to see them, and they're industrious little workers there. And the honeybee can pollinate quite a few plants, as you can see from this scrolling marquee here. And yeah, so they're useful. They are what we'd call a generalist, right? If you have honeybees, they can be useful because they can go around and they can pollinate quite a few plants, and they're flexible, right? However, many times you actually want a specialist. So this is the yellow-faced bumblebee. This is one that you can see quite a bit in the Bay Area. And this is also hanging out on the buckwheat in my garden. And the thing is that the yellow-faced bumblebee is a more efficient pollinator of tomatoes than honeybees or humans, right? They've done studies, and they're not even sure why. There's some reasons why it might be better, but they think also it's just kind of good at timing. Like it just kind of knows when is the right time to do that pollination, right? So it's actually incredibly important that we have this specialist yellow-faced bumblebee here. And then I wanted to show you my favorite California specialist bee. This is the California mountain digger bee, and it is so cute. It's like gray and fuzzy, and it's adorable. So I love when the digger bees come to the garden. And digger bees are one of the species that use buzz pollination, which means that they flap their wings at such a high frequency that the pollen bursts out of the flower, the parts holding it. And I was watching a video about it, and all the comments were actually really inappropriate because it's shaking pollen loose with a vibration. So it's but they're the only bumblebees and certain types of bees are able to actually do buzz pollination. So if you want to get all of the pollen from a plant, you have to have something that is capable of doing it. So you either need like a bumblebee or a digger bee, or you actually need a tuning fork. So you can do it with a tuning fork if you want to go around all the flowers with a tuning fork. So this is the point. Why are specialists important, right? So you can go and use iNaturalist in order to find, this is this amazing site where you can find observations. These are my own observations in my garden. You can go and see all the ones around here. And they have this fantastic API and data dumps that you can use. So for those of you who like messing with data, it is a really, really fun set of data. So for example, if you have a 6-year-old that's begging to see a bobcat, you can stalk the bobcats and figure out exactly where to see a bobcat. And I'm pretty sure they don't eat people, so I think this is a great activity to do with 6-year-olds. So I made a little app for today's talk in order to play with the iNaturalist data. So here we've got this, this is a fast API app, right? So we've got an endpoint where we can search to see, okay, what are the active bees around here? So we can see the most active one is in fact that honeybee, but then we do have the yellow-faced bumblebee, so we can see quite a few of those, right? And then we can see the taxon, and then I can go and I can take that taxon and be like, okay, if I really want to see that yellow-faced bumblebee, well, when's the best month to see it, right? So as you can see, the best month, is May. That's true for many of the bees, although there's another one. The fine striped sweat bee is this amazing bee. It is entirely turquoise. Well, the females are entirely turquoise. The males are only half because reasons. Here we go. This one is most active in July, right? So this is the one I love when July comes around because I get to see the turquoise all around the garden. All right. So anyway, what the heck? Why did I just talk about bees for so long, right? What do bees have to do with AI and testing and all of that? So I promise I'm going to relate these topics. So the LLM is a generalist, right? That's its whole point. An LLM is a language model that they trained on so much data with so many flops, like so many training iterations that it was able to achieve general purpose language understanding and generation. And we didn't know this would happen until they threw enough training data and enough training cycles at these models. And then they're like, whoa, you see these like jumps, right? This is from this paper where you see this sudden jump is like, oh man, once we train it on enough stuff, suddenly you can do anything, right? So before we had to build our own models to do sentiment analysis and summarization and translation. Now you have an LLM and it can do all of those things, right? So that's what's amazing about LLMs, why they've taken the world by storm here, is because of this general purpose ability, right? It is a generalist. And so LLMs have seen quite a lot of Python data, so they can write Python tests, right? So, as a test of this, I took this, the Fast API app here, and I didn't write any tests for it. I did write test fixtures, right? So I told it, here's how you make the app, and here's how you set up the test database, right? So I set those up. That can be a bit tricky. So I wrote those two fixtures, and then said, hey, LLM, write tests for my app, okay? And using this sort of prompt here. Right, so write tests for all the routes. So this is what GPT-5 came back with. It wrote 10 tests. Only 8 out of the 10 tests passed, unfortunately. And you might wonder, like, well, why couldn't it get that last test to pass? That test did actually pass when GPT-5 ran it the first time. But then when I reran it, there was a SQL integrity error because of uniqueness constraint, because it didn't clean up its work properly. And so I consider those failing. So anyway, it's interesting. Like here I'm using these LLMs in an agent mode. I'm using this in GitHub Copilot. So it is able to iterate on its work. But the LLMs don't always realize that actually you should run your test twice, right? To see like, okay, they ran the first time. Are they going to run the second time too, right? So GPT-5, it got 8 out of 10 tests passed. And it had 75% coverage of the routes file. It took about 2 minutes, and it took 500,000 tokens to do that. I then ran the same test with Sonnet 4.5. That one wrote 61 tests. It's a bit of an eager beaver, bit of an overachiever, but maybe that's good because it did achieve 96% coverage, right? So that's really, really quite high coverage. It did take 6 minutes to do it, and it took 1.3 million tokens. Worked for longer, but arguably got better results. We're going by those metrics. So I tested a bunch of models, right? Like to see what the variance is. And there's so much variance, right? This is like the model really does matter. So we go between 4 tests with 81% coverage all the way up to those 61 tests with 96% coverage. So there's a big variation here. And it's super interesting to see the different ways that they wrote the test, the different styles. And I do have all these saved out if you want to just look at people's tests later, or LLM tests. All right, so you're looking at that thinking okay, well, maybe the solution is we can just use Sonnet 4.5. That looks pretty good, right? But the thing is, there's a lot to be improved in these tests, right? The first obvious issue is that none of them got 100% coverage, right? And how, if we're humans, so the first question is, should you have 100% coverage? How many of you here think you should strive for 100% coverage ideally? A few people. Guido, okay, great, thank you, Guido. That's what I would like 100%. It makes me feel good. Because there are arguments, how many people think that actually, no, you should do mostly and just be okay with some edge cases just hanging out? Yeah, there's a lot there. So there is a debate about should you strive for 100% coverage, but I would like to have 100% coverage because then we're not debating what can be left out, right? We're just well, we're getting 100%, that's it, right? So if I want to get 100% coverage, how do I do it? I run coverage, and I look at the coverage report, and I'm like, okay, what lines am I missing, right? So what I did was that I wrote another prompt that said, all right, you're going to generate the coverage report, and I got a report that actually would show the specific lines, because if you just do the line numbers, that's not going to work. LLMs don't usually look at line numbers that carefully. So I wanted to get the exact lines. So this one dumps out the line, so we can see here's the line, this one's covered, this one's not covered. So we pass all that to the LLM and say, hey, you're going to look at this, you're going to figure it out, and you're going to add tests to cover the missing lines. So then I rerun with that. With Sonnet 4.5, it got to 98%, and then was like, you know what? The last two lines, they don't really matter. We're going to ignore them. Now, here's the thing. Like, this was with me I did not go back and forth with the LLM, right? I could totally go back and forth and say, no, I really, really want 100%, and it would make it work. It can get there, right? You have to, like, convince it, like, you know, that you really want it to work. I did also try with GPT-5, and it did get to 95% coverage when I gave it that prompt. So if you give them a prompt that, hey, you do care about coverage and this is how you do it, this is how you figure out what's not covered, then you can get much, much better coverage, right? And interestingly, this time around, it wrote less tests. So we managed to get to more coverage with less tests, which is interesting to think about. Like, then you want to, like, shrink down your tests to the minimal ones, right? All right, so we got to higher coverage, but those tests still have problems, right? So we've got, in those tests, we've got redundant test code, right? Like, why do we have 54 tests, 61 tests? We've got fake data that's just not really good fake data. We're missing edge cases. We think we have 100% coverage, but we don't really. So we're going to bring in the specialists, the libraries that are going to help us write better tests for Python. So the first problem we have is redundant test code, right? These are some LLM-generated tests. One is for sorting activity descending. The other one is for sorting activity ascending. Those are two very similar tests, right? And the only thing that's different is that, you know, which order they're going in, right? So this is a perfect opportunity to use the PyTest parameterize function, where you can just say, hey, these are the things I want to parameterize about my test. You're going to, you know, for each run of the test, you're going to parameterize it, and then you can just put in the arguments and say, you know, this is the parameter I'm bringing in, and then you use that in your code, right? So now we have a single test that's parameterized, and now you can look at it and be like, okay, that's what this test is doing. So that's a great thing you can do with PyTest is parameterization. It makes it easy to see when tests are really similar and only differ in one or two ways. The other thing you can do is that if you're constantly making the same fake data, fake test objects, fake mocks, you can use a fixture, right? So fixtures are particularly good for, like, fake database data. You're like, okay, for a bunch of tests, I need to have an example trip in the database. This is like a bee watching trip, like we take all the time. So I'm going to put my bee watching trip in the database, and then I'm going to give that to the test. And then after the test completes, I'm going to clean it up and remove it from the database, right? So this is a great thing to use a PyTest fixture for, and then you can bring that fixture into any test where you need it just by referencing it in the arguments of that test. So this is what helps with our redundancies, is parameterize and fixtures. So you definitely want to be using those. The next problem we have is the fake data is not fake enough. If you ask LLMs to generate names, they are the most boring names in the world. Oh, I don't know if anybody has these names here. Sorry. But it's always going to be John Doe or Jane Smith. It's like over and over. Do we have any John Does or Jane Smiths here? Okay. It's just they don't represent the beautiful lingual diversity of the whole world of names, right? And there's so many things that can be different about names. You can have non-ASCII characters. You can have hyphens. You can have multiple names, right? You can, have like 6 names in your name. You can have accents, diacritics, hyphens, all that stuff, right? And there's this amazing, if you haven't seen it yet, it's the falsehoods that programmers believe in. These are all the falsehoods we believe in that make our programs bad because we don't properly account for them. So the one that started off was the falsehoods about names. So all the things that we think are true about names that are not true. So you really should read through a lot of these falsehoods here, because it'll make you realize that all of your tests are wrong or are not reflecting the true diversity of the world. Because a lot of times our programs are dealing with actual human data, and humans, we have all different ways of doing things, right? So it's super important that we account for that. My kid actually had to get her birth certificate redone because I wanted to have camel casing in her last name. because I was raised in a Java household before Python existed. And so I wanted it to be, because my partner's last name is Gray, right? So I wanted it to be Gray, capital F, Fox, right? Like that's how you'd write a class, Gray Fox. And they couldn't understand it at all. They added a hyphen. I was like, we're not doing hyphens here. So we had to like go back and forth with the hospital and the thing. And anyway, so that's why it's really important that we remember that, you know, some names can be camel cased, except they couldn't. We gave up. Ideally, in another world. All right, so what's the solution? That you can use libraries that are designed to generate realistic fake data. The one that I use all the time is Faker. There's another one called Mimesis. But I use Faker the most. It's easier to pronounce. And it has all these abilities to make fake data. So you need names, coordinates, phone numbers, credit cards, currencies, airport codes, like all of those kinds of things that you might be dealing with, they have fake providers for. And so you can get much more representative inputs, right? Especially useful for addresses. My gosh, for any of you who've worked in the geography space, you know that addresses can be vastly different across different countries, and it's really helpful to be able to represent that in your testing data. The next problem is that a lot of times LLMs, they want to make themselves look good. So they'll like write tests that pass, but they aren't really testing as much as they could, right? So if you're, you know, this in the example is testing a JSON endpoint. So when the JSON comes back, it says, oh, okay, does it have a field? Great. Does it have another field? Great. Okay, we're done. So instead, if I was actually writing this test, I'd be like, well, what's in those fields? I care about what is in those fields. I want to actually make sure that the data in those fields is what I expect it to be. So you can either, like with a JSON response, you can go through and like manually check every single freaking field, or what I like to do is snapshot testing. So here what you do is you're testing your JSON API, you take a snapshot of it, and you say, okay, I'm going to save that snapshot, and then the next time I run the test, we are going to run the test against that snapshot and see, hey, does that snapshot match, right? And if it doesn't, then you have to update the snapshots. And then what's really cool is that when you're sending your change for code review, you can see everything that changed in the snapshots, and you can say, oh, yeah, that was an intentional API change, or, oh, that was an unintentional API change. So I pretty much use snapshot testing for all of my API-based apps now, so that I can see exactly what's changed over time and do a full diff. And I've like discovered so many bugs from this that I wouldn't have thought of otherwise, so it's super, super helpful. All right, so is that enough? Do we now have perfect tests that Pamela loves and thinks awesome and, you know, I can rubber stamp? No, because the thing is, even if it says that we have 100% coverage, that doesn't actually mean 100% coverage, right? Right? 100% coverage means every line was run. You can even enable what's called cyclomatic complexity checking, where you check that every flow in an if statement was covered. But even that is not 100%, because what you don't know is, like, what about all the different kinds of data that could flow through the system, right? Have we flowed all the possible kinds of inputs through the system to see how the system responds, right? And there's all these kind of edge issues, like, you know, numbers that are huge, that are out of bounds, that are negative, that are zero, right? And these are the things that will lead to 500s and, like, you know, wake you up in the middle of the night and, you know, not so fun. So the solution here is to use what's called property-based testing. And luckily, we had a talk earlier today entirely about it from Zach. So he was talking about hypothesis, and that's the main package that you want to use for property-based testing in Python. And luckily, it also has a pollinator logo, the dragonfly, which is awesome. So hypothesis is like the go-to for property-based testing. And basically what it's going to do is be able to generate all these possible inputs for your function or program based off of, like, oh, it takes integers. Okay, we're going to try all these different kinds of integers. Oh, it takes strings. Let's try empty strings. Let's try really long strings, right? So it's really, really helpful to figure out what you forgot about, what you didn't cover, right? So for example, like with the endpoint that takes in a taxon ID, right? I can just say, okay, hypothesis, you know, I just need to test all the integers, right? And so it's not gonna throw every single integer, because that would take like infinity time. But what it'll be like really smart about what integers it throws at it to try and figure out what, you know, where it's most likely to fail. And we could also, you know, specify mins and maxes and different types, and it'll just really smartly throw things in there. So I ran this. I did get an immediate error. You can see this is a SQL Alchemy error because we're using SQL Alchemy. And here it basically said like, we got like a 500 error when this endpoint received a huge integer, right? So I can look at that and be like, okay, well, in case somebody, like, because generally you never want your server to give a 500, right? Because if your server gives a 500, then you got to wake up, you got to look at the 500 logs and see, is that a good 500 or like a bad 500, right? As an API, you want to return back like an a 400 code to be like, hey, you did it wrong, right? It's not my fault, it's yours. So what we want to do is put in some additional validation in our endpoint to say, hey, if we get a big int that we can't handle, we're just going to throw back an error to the user that says what they should be using instead, right? So it's definitely like if you are doing any sort of API, I think that property-based testing is particularly important for you because the developers using your API are going to throw everything at that API, and you can just throw it at the API ahead of time. Now, schema thesis is built on top of hypothesis and is specifically if you are using, if you're building an API using the open API specifications, like using Swagger, using Fast API, which I think many people, how many people are using Fast API here? All right, yeah. So with this, like this is literally what I did, right? I just said, all right, you're going to, this is the Fast API, generated open API specification. Now test it. So it goes through every endpoint. It looks at the parameters for the endpoints, and it uses hypothesis to throw lots of values at those endpoints. And this found the exact same error. This was the first error that popped up, was that issue with the endpoint with the really large numbers, right? Now in this case, it says, okay, you can reproduce it. So both of them, I didn't point this out, but with hypothesis, it says, here's the falsifying example, so you can see how you can reproduce it with that test. And then with schema thesis, you get a curl command, right? So it's like, oh, okay, you want to reproduce it? Here's the curl command, right? So that makes it super easy to tackle. All right, so now that we've seen all that, should you use LLMs to write your tests? It is entirely up to you. I am not going to be one of those people that say that you have to use AI or get out of the industry, because that's a shit thing to say. Because you should be able to be a programmer even if all you're using is like, I mean, I used notepad.exe for like many years, right? You can write programs with all kinds of tools, and you can lovingly handwrite your, HTML, or you can like have someone generate it for it, right? Like I still write HTML for fun as like a meditation, but I'm the only one who does that. So it is up to you, right? Everyone should belong in the Python community, whether or not you use AI for something. However, if you are going to use LLMs to write your tests, it helps to seed them with good ideas for how they can write better tests. It also helps to start off with some good fixtures, right? So start off with your app and DB fixtures, and then give your LLM good guidance as to how to proceed, right? And here's a prompt for an example prompt, right? So you're going to write the test. You're going to use the fixtures in the comp test. You're going to use these guidelines. Make sure you're using parameterized tests. Use fixtures. Use faker. Use snapshot testing. Run the coverage, right? This one is kind of a simplified prompt here. You could also ask it to use hypothesis and schema thesis here. Whatever, the thing is, I have my preference for how I'm writing tests. It's not necessarily your preference, too. All right, so I wanted to give some ideas of my favorite tools that we have from the Python ecosystem, but it's also up to you what you think makes for a great test. So you can put all of that in, in your prompt, and so that you modify it. Okay, so there we go. And now, going back to bees. So should we use bees to pollinate our flowers? Yes, probably. But we should also, consider the specialists. And so I do have a huge amount of seeds with me today. This is why I'm wearing 3 fanny packs here. Thank God for my mom. I messaged my mom last week. She was coming up. I was like, Mom, I need all your fanny packs. So here we have many different kinds of seeds here from the Xerces Society pollinator mix. If any of you want to seed your gardens to get more specialists in your gardens, please hit me up so that I don't have to carry 3 fanny packs worth of seeds home. And that's how I managed to relate AI to bees. All right, that's what I have for you today.
In fixing this AI and LLM for tests, do you think if test-driven development can make any difference with coverage, since you write tests before and then failing test after, kind of something like that? So how is your experience, maybe if you've tried with all this coverage thing that
So the thing with test-driven development is you have to have a really good idea ahead of time of what you're building. So if you know really exactly what you're building and have a very strict definition of it, then test-driven development can be really, really good, right? But if you're kind of like more in like kind of like a experimental prototyping phase when you're first building the thing, where you're not quite sure what it's going to look like, and then it can be pretty annoying to have to like keep on updating those tests. So yeah, I think it's great if you have a strict enough definition going started with to do test-driven development. But now a lot of people are doing using LLMs to be able to prototype things faster, and so I would imagine so I do, when I'm using LLMs, I do use what's called like PRD-driven development, where I'll like ask the LLM to help me like write the docs for it. So like this one, I think I did do, so because I used LLMs to write the code for this one, and so I had it like write the docs first. I don't know if I checked them in or not. But yeah, so you can I think more people are going to be doing like that sort of development to get the app running, and then when you're like, okay, this is a nice app, then it's nice to write tests. So it just depends on how concrete your product is defined.
In those cases, maybe the LLMs can write better unit tests if you have tests and failing tests before, maybe with all the things that you mentioned, like fixtures and all those things built into it.
Sorry, what was?
In those cases, if we are doing test-driven development, is LLM a one-shot approach maybe in that case, or it still requires all the things that you talked about, like hypothesis and all those great things?
I think it's always good to use all those tools. It depends on what you're building, but
right.
Yeah, it's kind of personal.
Okay, thank you.
Check. I just wanted your opinion on what you see being the future of writing tests, especially with like different user interfaces, different user experiences, to make it easier to write tests, easier to manage tests.
Like future of writing tests, it is hard to hear.
Yeah, this is like an ideation thing. It's like, are there?
I feel like generally, I think that people are moving away from unit tests and more towards end-to-end and integration tests. So I do feel like that's a feature of tests, is that for like user-facing web applications, it's probably more worth it to spend your time on like the playwright tests that are testing the whole experience versus like the little individual units. Especially as like, if you imagine if people do move more towards vibe coding where they're not looking at the code, well then what matters is the end-facing user experience. So I think like going more towards end-to-end and integration is the general trend, if that answers my question. Thank you.